Welcome to the semester review of our chemical names and formulas, also known as nomenclature. Please have out your hot pink review sheets, as well as a periodic table to guide you. The first question from your review that I'll be working is number 75. It says, where are the following located on the periodic table? Well, the easiest way to do this is to locate your metalloids first, and they're highlighted here in red. Once you know your metalloids, then you can memorize that everything to the left is a metal, and everything to the right is a non-metal. Okay, except for hydrogen. Hydrogen is also a non-metal. Number 76 says, what are cations and what are anions? Well, cations are positively charged ions that have lost electrons. On the other hand, anions are negatively charged ions that have gained electrons. It says, which of the two are formed from metals and which ones are formed from nonmetals? Well, if you look at your periodic table, we said that cations are positively charged. So you can look up here and see the ones that are positively charged are in the metals section. And the ones that are negatively charged are in the non-metals section. So you can figure that out just by looking at your periodic table. Number 77. How can ionic compounds be recognized, and what type of bond do they have? Well, ionic compounds are formed between a metal and a nonmetal, a metal and a polyatomic ion, a polyatomic ion and a nonmetal, or two polyatomic ions. So there's 4 different combinations here. You just need to memorize those. The type of bond they have is an ionic bond, which is an attraction between a positive and a negative charge. Number 78, which type of ion comes first in an ionic compound formula? You always write the positive ions, which are the cations, first. They're the metals on the periodic table. And also the polyatomic ion ammonium, which is positive, will be written first as well. Number 79. How can molecular compounds be recognized, and what type of bond do they have? Well, molecular compounds are made of 2 nonmetals or a nonmetal and a metalloid. So it's very different from an ionic compound. They have covalent bonds, which are bonds formed by sharing of electrons. And if you look on your periodic table, you'll find those in this section highlighted in red. So if it's 2 of these elements that are in this section bonded to each other, you know it's a molecular compound. Number 80. The elements of which group or family do not typically form bonds, and why not? The answer is the noble gases, and the noble gases already have 8 valence electrons, so they don't need to bond to something else to get what they already have. So their orbitals are full. Remember the electron dot diagrams? They have 8 valence electrons, so they're not very reactive and do not usually form bonds. Okay, number 81 through 85. It says classify each of the following as ionic, molecular, or an acid. Well, before we do that, we need to know what each of these are. An ionic compound, we said the 4 different combinations earlier. Molecular, we said it was between 2 nonmetals or a nonmetal and a metalloid. And acids. Acids always start with hydrogen. That's the best way to remember them. So it's going to be hydrogen in a nonmetal or hydrogen in some sort of polyatomic ion. Those are your 2 options. So looking at these 5 questions, let's figure out what the compounds are made of. Number 81 is sodium and then nitrate. So sodium is a metal. Nitrate is a polyatomic ion. So this would make this an ionic compound. For 82, This starts with hydrogen, so we immediately know it's an acid. For 83, we have phosphorus and oxygen. So if you look on your periodic table, you'll see that phosphorus and oxygen are both nonmetals or metalloids. So this is a molecular compound. Number 84, this compound starts with hydrogen, so we immediately know it's an acid. And then 85, we've got two polyatomic ions here, which is an ionic compound. So all you have to do when you're trying to classify these is to look at what they're made up of. Okay, so if it starts with hydrogen, it's an acid. If there's two nonmetals or a metalloid, then it's molecular. Everything else is going to be ionic. Okay, ionic compounds, write the name. This is what y'all struggle with the most. So you need to know a few things before you can write the name. So in order to write the name of an ionic compound, you're going to name the metal ion first, then the nonmetal ion. So how to name metal ions? For transition metals, which are the ones in the D block or in the center, you must look on the back of the periodic table on the right column, and you'll see it says common metal ions because sometimes these transition metals have more than one oxidation number or charge. And you must write that in a Roman numeral when you're writing the name. So for example, you can see on the back there's two types of coppers. There's copper that's +1 and copper that's +2. Well, in order to distinguish the two, when you're writing the name, you have to use a Roman numeral 1 or Roman numeral 2 after you write copper. For all other metals, you just write the name. So sodium, for example, Na, you just write sodium. For the nonmetal ion names, for elements, you'll just change the ending to "ide." So for example, chlorine, it's changed to chloride. For polyatomics, you won't change the ending. So PO4 - 3 is just phosphate. So let's try using some of these rules. So for the first one, we have NaC2H3O2. Well, Na is my metal ion, and as I can see in my example, I'm just going to call it sodium. If you look on the back of your periodic table, you'll notice that C2H3O2 is a polyatomic ion known as acetate, and you do not change the ending of your non-metal polyatomics. So you just write sodium acetate as the name for number 86. Okay, for 87, it's Cu3PO4. Well, copper, as we said in our example before, is one of those elements where you'll have to say if it's copper 1 or if it's copper 2. So you have to look at the way that the bond is formed here. Well, phosphate has a charge of -3. Copper, therefore, has to have a charge of +1. Remember when we crisscross the oxidation numbers in order to form these compounds? That they will crisscross and drop. So because it's Cu3PO4, then I know it's copper 1. So in this case, I'll have to write copper and then a Roman numeral 1. And then it's the polyatomic ion phosphate. So I just write phosphate. For number 88, SnCO3 2. Well, tin is another one of these another one of these transition metals that has two different oxidation numbers. So the way that I know that this is tin 4 is because if I look on the back of my periodic table and find carbonate, carbonate has an oxidation number of -2. So when I originally formed this compound, it would be SN2CO3 4, but then it reduces down to SnCO3 2. So this is tin 4 carbonate. Okay, for molecular compounds, it says to write the name. Molecular compounds are a lot easier to name because you just use prefixes and then change the last element's ending to "ide." So, for number 89, because there are 2 arsenics, we call it diarsenic, and because there's 3 sulfurs, we change the ending of sulfur to "ide, and we'd say it's diarsenic trisulfide. For number 90, there's only 1 xenon, but there's 4 fluorines. Well, we change the ending of fluorine to "ide, and we add the prefix for 4, which is tetra. So it becomes xenon tetrafluoride. So molecular compounds are a lot more simpler to name. Just remember to use the prefixes. Acids, write the name. Acids are usually the least favorite of all of my students because they are the most difficult to name. The common question is, when do you use hydro and when do you not use hydro? Well, we know acids always start with hydrogen, so whether or not you use hydro depends on the second element or polyatomic ion. If the second portion that makes up the compound is just an element which is found on the front of the periodic table, this is when you use hydro. When it's a polyatomic ion that's found on the back of the periodic table, do not use hydro. And instead of using hydro for the polyatomics, you'll use a different rule. If the polyatomic ends in "ate", you'll change it to "ic", and if it ends in "ite", you'll change it to "us". Okay, so for number 91, we have HBr. Well, Br is found on the front of the periodic table, so I'm going to use hydro. So this will be hydrobromic acid. And you always change the ending of an acid to "ic" if it's in this form. So hydrobromic acid. For 92, the name will be carbonic acid. Because if you look up CO3 on the periodic table, well, it's going to be on the back of the periodic table, it'll be called carbonate, and you'll change the ending from "ate" to "ic". Okay. And the ways we said to remember this was to remember a little saying, which is, "Don't bite, it's infectious, and what I ate was icky." So you can remember to change "ate" to "ick" and "ite" to "us". Okay, molecular compounds, writing the formula. So now we're doing this in reverse. Well, this is very simple to do because the subscripts that I'm going to write are going to be based on these prefixes. So I have dibromine pentachloride, which just means I have 2 bromines, and pent is the prefix for 5, so I have 5 chlorines. For 96, dichlorine means that there's 2 of them. Then hept is the prefix for 7, an oxide, so 7 oxygens. And that's how you write molecular compounds. For everything else other than molecular compounds, you have to crisscross oxidation numbers in order to write the name. In order to write the formula. So for example, hydrofluoric acid. Well, we always know that the cation is hydrogen, and it's H+1. Well, it's fluoric, so I know that fluorine is going to be the anion, and its charge is -1. And I'm just getting this off of the periodic table. If you look at the top, there's numbers that are circled with charges. So group 1's +1, group 2 is +2. It skips through the transition metals. Group 3 is +3. Group 13 is +3. Group 15 is -3. Group 16 is -2, and group 17 is -1. So because fluorine is in group 17, the charge on it's -1. I'm going to crisscross these oxidation numbers, and it forms HF. Okay. For nitric acid, well, there's no hydro in the name of this acid, so I know it has to be a polyatomic ion that's mixed with hydrogen. So I always have hydrogen as the cation portion. The anion portion is going to have to be some sort of polyatomic ion. We have two options. It's either going to be nitrite or nitrate. Well, remember, what I ate was icky. And don't bite, it's infectious. So, I know because the ending is ick that it had to be nitrate. And nitrate is NO2, NO3 minus 1. So when you crisscross the oxidation numbers, you just get HNO3 as your final answer. Okay, so for more information on chemical names and formulas, please visit my website at academicchemistry.pbworks.com. There are quite a few resources on that webpage. It says go to the navigation bar on the right side and click on Nomenclature. And under Nomenclature, you will find additional resources. Good luck studying and good luck on your finals.